All right, if you're a developer, you live this dilemma every single day, right? Do I code something fast or do I make it run fast? It always feels like a trade-off. Well, today we're going to talk about Nelson's MEX interface. And trust me, it's the feature that basically says, hey, you don't have to choose anymore.
Okay, so to really appreciate why this MX thing is such a big deal, we got to take a quick step back. Let's look at this fundamental clash in the coding world, this constant battle between how fast you can write your code and how fast the computer actually runs it. So you've got two camps, right? Over here, you have Nelson. It's awesome for getting ideas off the ground quickly. Rapid prototyping, playing around with data, using all these powerful, high-level commands. It's all about developer productivity. But then you have the heavyweights, languages like C and C++. These guys are the undisputed champs of raw speed. They let you get right down to the metal, controlling the hardware directly for maximum performance.
And for what feels like forever, the rule's been pick your poison. You either get to develop quickly, or you get that blazing fast execution speed. But what if that's a false choice, What if you could actually have your cake and eat it too?
And that is exactly the problem Nelson sets out to solve. Instead of making you choose a side in this war, it hands you the tools to build a bridge that connects these two very different but equally powerful worlds.
Okay, so here's the crucial part about the MX interface. Think of it less like a one-way street and more like a superhighway with traffic going in both directions. It's a two-way gateway. This means you can take your super-fast C code and pull it into your Nelson environment to speed things up. But, and this is just as cool, you can also be working in a C program and call on Nelson's amazing computational engine to do the heavy lifting.
So yeah, that bridge analogy we mentioned, it's perfect. The MEX interface is literally the bridge connecting that easy-to-use, super productive world of Nelson with the, let's face it, raw, untamed power of languages like C and C++.
All right, so how does this bridge actually work in practice? Let's get a little more technical for a sec. We'll look at it from the C side of things. Let's say you're building a C application and you want to borrow some of Nelson's brainpower. Honestly, Nelson makes this surprisingly easy with what's called its Engine API. It's basically a simple four-step process. Think of it like a little dance. Step 1, you use eng open to, open the gateway and start a conversation with the Nelson engine. Step 2, you start exchanging data, passing variables back and forth with eng put variable and eng get variable. Easy enough. But step 3, that's where the real magic happens. With eng eval string, you can literally tell Nelson to run any command you want right from your C code. It's like having a Nelson command line inside your C program. And finally, step 4, you just say goodbye with eng close. That's it. It's that straightforward to wire Nelson's power right into your own apps.
Okay, so building this bridge is not just a neat party trick for programmers. This unlocks some seriously powerful new capabilities for your projects. So let's talk about what you actually get out of this. First up, and this is the big one, performance. We're talking about a serious speed boost. The strategy here is smart. You use Nelson's own profiler to hunt down those 1 or 2 bits of your code that are the real bottlenecks. The parts grinding everything to a halt. Now, instead of throwing out your whole application and starting over, you just surgically rewrite those specific functions in C. You compile them as a MEX file, and poof, you can call them from Nelson. This lets you tap into all that low-level goodness, like OpenMP for running things in parallel, or SIMD for hardware-specific optimizations. You get a massive performance gain, but only where it matters most.
And the second huge win? Integration. Look, there are literally decades of incredible, battle-tested, super-optimized C, C++, and even Fortran libraries out there. The MEX interface means you don't have to reinvent the wheel. Not at all. You can just plug those existing trusted libraries right into your Nelson workflow. The amount of time and effort this can save you is it's massive.
Okay, let's zoom out for a second, because it's important to see that this bridge to C++ isn't some random bolted-on feature. It's actually part of a much bigger idea, a core philosophy behind Nelson, to be this totally open, totally connected ecosystem.
So yeah, the MEX interface is a really important piece of the puzzle, but it's just one piece. Nelson also plays nicely with Python. It can talk to web services using RESTful APIs, it integrates with Windows COM components, it handles all sorts of standard data formats. The whole point here is that Nelson is designed to be the central hub for your entire workflow, not some isolated island you get stuck on.
All right, we've covered a lot of ground. So what's the bottom line? If you're going to remember just one thing from all this, what should it be?
It all comes down to this. You don't have to choose between speed of development and speed of execution anymore. That's a false choice now. The MX interface gives you the ultimate flexibility. You can use the right tool for the right job all inside one workflow. You get to do all your creative work, your prototyping, in Nelson's awesome high-level environment, and then bam, you strategically inject the raw power of C++ right where you need it most.
So there you have it. Nelson gives you the bridge. It connects these two incredibly powerful worlds of programming. The only real question left is, what are you going to build with it? Thanks for tuning in.